All right, today we are diving into a puzzle that has, believe it or not, stumped engineers for decades. We're talking about how you teach a machine to do something a toddler can do without a second thought. Pick the perfect tomato. I mean, just look at this. It's a tomato. If you were standing right there, you just reach out, give it a little twist, and snap. It's yours. It's an action so easy, so intuitive, you don't even have to think about it. So you gotta ask, right? How hard could it possibly be to build a robot that can do that? Well, it turns out that simple little move has been a huge headache and a decades-long obsession for some of the sharpest minds in robotics. And let's be clear, this isn't just some fun little engineering challenge. This is about serious money. Get this, up to 50%, half, of all the labor that goes into growing tomatoes comes from that one single action, picking them. That is a massive bottleneck in our entire food supply chain. And that incredible cost, well, that's really at the heart of what we can call the tomato picking problem. It's a huge economic and logistical hurdle for modern agriculture. So why is picking by hand such a challenge? Well, for starters, it's just brutal work. You're often in these hot, punishing greenhouses. Human efficiency, it goes up and down. Labor costs are always on the rise. And if you don't pick that fruit at the absolute perfect moment, you risk losing a ton of money. Okay, so the obvious answer seems to be, let's automate it. Let's just build a robot to do the job. Easy, right? Well, for decades, pretty much every attempt to build a robotic tomato picker has been, to put it nicely, a bit of a disaster. Let's dig into why. And, the history here just shows how slow and painful this progress has been. We saw some early tries back in the 90s hit around a 70% success rate, but they still needed a human basically holding their hand. Now, fast forward 20 years, and you've got designs that were actually doing worse, with success rates dipping below 60%. Even the later models barely cracked 72%, and they were painfully slow. The needle just wasn't moving. So, what was going so wrong? Why was this so hard? Well, it usually boiled down to a few key problems. First, mechanical damage. The robots were literally squishing and scratching the fruit. They were also way too slow, some taking almost half a minute for a single tomato. They'd get confused by leaves, by shadows, by changing light. And then you have the peduncle problem. That's just the fancy word for the little stem. The robots would rip the tomato off, but leave the stem, which completely ruins its shelf life. But that brings us to the hero of our story, a totally new approach designed from the ground up to solve all these old problems. It is time, my friends, to meet a smarter picker. The brain behind this new robot is an AI model called YOLO V8. Now, YOLO stands for You Only Look Once, and it's famous for being incredibly fast and super accurate, which is exactly what you need when you're trying to spot one ripe tomato in a whole sea of green. But a smart AI is only as good as its training. So to get it ready for the real world, the researchers use this cool technique called data augmentation. They'd take a perfect image, like the one on the left, and then they digitally rough it up, adding stuff like digital static. That's what you're seeing on the right. This teaches the AI to see past all the little imperfections, making it way more reliable out in the field. Of course, it's not enough to just see a tomato. It needs to see a ripe one. So the AI was trained like crazy to tell the difference between a raw green tomato and a perfectly mature red one. This makes sure the robot only picks what's actually ready to sell. Okay, so the robot can see, but how does it pick? This is where the new design gets really, really clever. Meet the non-contact end effector, which is just a fancy name for the robot's hand. And its entire design is built to solve that biggest problem from the past. No more crushing, no more scratching. And the picking process itself, it's so elegant. First, this ring just loops right under the tomato. Then it slides over to guide the stem into a little cutting slot. A tiny motor pulls a wire, a little blade rotates, and snip, the stem is cut clean. Then it just resets. The genius part is the robot hand never even has to touch the tomato itself. No squeezing, no bruising, nothing. Now, just as important as the hand is how the arm moves. A lot of older robots used what's called joint space motion, which is kind of this big, sweeping arc, really risky when you're around delicate plants. This new robot, it uses Cartesian space motion, and you can think of that like a surgeon's steady hand. It moves in a direct, precise, straight line right to the target. It's absolutely essential for navigating a crowded greenhouse without breaking things. So we've got a smart AI brain, a super gentle hand, and these incredibly precise movements. But did it all actually work? Let's check out the robot's final report card. First up, its vision system. Could it actually find the right tomatoes? The result? An amazing 91.5% accuracy. It could find its target with almost perfect precision. That is a huge deal. And now, the main event, the picking. What was the robot's overall success rate? A whopping 83.3%. Now, remember those old robots struggling down in the 50s and 60s? This is just a massive, massive leap forward. Okay, but what about speed? How fast could it go? The average picking time was just 9.5 seconds per fruit. That's more than twice as fast as some of the older guys, and it's a speed that finally makes this technology a real possibility for farms. Let's just put all these numbers side by side so you can really see the full picture. Where the old robots failed a third of the time, or even more, this new one succeeds over 83% of the time. Where they took up to 24 seconds, this one is under 10. And it almost completely eliminates the fruit damage that was so common before. This isn't just a small step up, it's a genuine breakthrough. So, what does this all mean? Why should we care so much about one smart tomato-picking robot? Well, let's zoom out and think about the future of the harvest. In their paper, the researchers themselves say that their work provides a technical support for the automated harvesting of tomato-picking robots. And that's key. This isn't just about one specific machine. It's about laying the foundation, the technical groundwork for the entire future of automated farming. And that brings us right back to where we started, that simple tomato on the vine. We just saw a robot finally master one of the trickiest harvesting jobs out there. So if we can crack the tomato problem, what comes next? What happens when robots like this can harvest everything? Just think about what that could mean for our global food supply, for the future of how we work, and